Hi, in this video I'm going to discuss Le Chatelier's principle, which is among the most important principles within chemical equilibrium. So to define Le Chatelier's principle, I'm going to type it here because it is a longer definition. So Le Chatelier's principle states that if a system at equilibrium is disturbed, the system will shift its equilibrium position to counter the effects of the disturbance. So I know that that definition is a little bit wordy, but I'm going to go through some examples of disturbances you may see to an equilibrium system. So if product is added, equilibrium will shift towards reactants. Right, if you have a system at equilibrium, right, so the rates between the reactants and the products are maintained. If you add in more product, you're going to have to add in more, you're going to have more reactant as well to maintain the rates. So the equilibrium shifts towards the reactants, and that means the equilibrium constant is going to change. Likewise, if you add reactant, then the equilibrium will shift towards the products. If you, let's say, if you change your volume or pressure, that is a disturbance as well. So say I have an equation with H2 plus Cl2 to give 2HCl. In this case, changing the pressure, changing the volume isn't going to cause a shift because you have 2 moles of reactant and you have 2 moles of product. So you're not changing the number of moles when you go from reactant to product or product to reactant. But if instead I were to have a reaction where it did change, so let's say I have the breakdown of O3 is in equilibrium with O plus O2. In this case, you have 1 mole of reactant and 2 moles of product. So if I increase the volume, equilibrium will shift towards the right. It'll shift towards the side with more moles because I've increased the volume. Same if I decrease the pressure, and right, increased volume and decreased pressure go together. Opposite, if I increase the pressure by decreasing the volume, equilibrium shifts towards the reactants because there's fewer moles of reactant than of product. Now, one more component of Le Chatelier's principle I want to go over is with temperature. And this can often be the one that confuses people the most. So I'm going to show an easy way to always know which way equilibrium will shift when the temperature changes. You need to treat heat as a product if exothermic. So if the delta H is less than 0, and treat heat as reactant if endothermic, right? If the reaction is endothermic, meaning you're given a delta H of greater than 0. So in the following reaction, CO, H2O, 6 2 plus 4 Cl minus is in equilibrium with COCl4 2 minus plus 6 H2O. In this reaction, your delta H is greater than 0. So what I do is I come over here and I make heat a reactant. Because we went over initially, if I add in reactant, equilibrium shifts towards the product. So when a reactant is endothermic, it's not releasing heat, so heat's not a product, it's absorbing heat, meaning heat is a reactant. So I put heat in the reactant column, and then that means if I increase the heat, equilibrium will shift towards the products. And if I decrease the heat and take some away, it'll shift towards the reactants. If it's an exothermic reaction, it would be the opposite. If I increase the heat in an exothermic reaction, it will shift towards the reactants. And if I decrease the heat in an exothermic reaction, it shifts towards the products. So those are the basic ways you can manipulate a system in equilibrium and cause disturbances, and the Chatelier's principle tells you what happens in order for the equilibrium to counter those disturbances.